So what we have is two lines and, some vertical and horizontal lines that we have the equations for. And we want to get the equations of these two lines. We also want to estimate where the two lines cross. Okay? So I'll start out with the equations of the two lines. And this is very straightforward because you've done that for homework for today. Okay? So this point here and this point here are going to have coordinates. This point is between -2 and 4. It looks like it's about halfway. So I'm going to say a reasonable estimate is x equals, what, 1, right? Add these, divide by 2, you get 1. So x is 1. And what's y? Well, that's tough. Oh yeah, it's on the line where y equals 11. Okay, so it's 1, 11. And this point is what? Well, we got the x-coordinate is 4. Now, let's see, between 5 and 11, the distance is 6, right? And this looks like it might be a third of that distance. Looks like a little more than a third, but a third's close enough for an estimate, okay? So a third of that distance would be 2. 2 units above y equals 5 is 7. So now we want to find an equation, right, for these 2 points. Well, I can draw a fundamental triangle, and I see that my run is 3 and my rise is -4, right? So my slope here is going to be -4/3. Might be a little small, but you know what to do there, okay? And then if I've got a point x, y on this line, I can do another fundamental triangle. Probably should have drawn it this side, okay? Then, let's see, this will be x minus 4, and this will be y minus 7. So the slope is x minus 4 over y minus 7. No way you can read that, but you get x minus 4 over y minus 7 equals -4/3. And you can solve this for y, right? Okay? Just following the procedure that you would have used for the homework today. And if you don't remember how to do that, it's amply covered in videos and class notes, okay? Then we have this line, and we can do exactly the same thing. Where'd my pretty green chalk go? My purple chalk? Okay. So, okay, I'm going to say this is about -2, 6. And this point is about, looks like 3, 11. Okay? Now I could clutter things up with a fundamental triangle, where I can also put a point x, y out here. And I can then see that, okay, let's see. You know what I did. Exactly what I've been giving people notes for doing. I know better, but I get in a hurry, so. And I know you do the same. You can't read that, so you can't prove that I was ignorant here. You prove that I was, actually, I don't think it proved that I was ignorant, because I do know what to do, but, a little bit careless, maybe stupid, okay? Yeah, careless, bordering on stupid, yeah, okay. I'll plead guilty. Okay, this should have been y minus 7 rise divided by x minus 4 run. I didn't realize what I'd done until I started doing the same thing here. It's wet, that's not right. Okay, so we're going to get y minus 11 over x minus 3, using the x, y, and the 311 point. That's going to be the slope of this line. But of course, we've got numbers that allow us to get the slope of the line. From -2 to 3 is 5, and from 6 to 11 is 5. So that's 5 over 5. Y minus 11 over x minus 3 equals 1. Okay? Then we can solve this, and we end up with, I'm probably going to mess this up, y equals x and then you're going to have minus 3, but then plus 11, so y equals x plus 8. And we can check that out. If x is negative 2 plus 8 is 6, that works. Okay? If x is 3 plus 8 is 11, yeah, that works. So I've got this one. Now let's see what happens if I try to do this one. Okay? I'm going to get, on the right-hand side, I'm going to have negative 4/3 x. And then I'm going to have negative 4/3 times negative 4. That'll be 16/3. And that'll be y minus 7, so that y equals negative 4/3 x. Okay, 7 is 21/3. Add that to 16/3, I get 37/3. Now maybe that's right and maybe it's wrong, but the other thing they're going to be asked to do is estimate the coordinates of this point. Okay? Well, the coordinates of this point, yeah, I got purple here. Okay? The x-coordinate is between, well, now it's between 1 and 4, right? The x-coordinate of this point. And maybe it's 1 to the right of this, but it looks like a little less than 1. But I'm still going to say, okay, maybe the x-coordinate here is about 2. I think that's off. I think it's maybe, like 1 3/4 or something like that, okay? So I'm not real confident of that estimate, but I'm going to just go with that for a ballpark comparison. So there's my x-coordinate. My y-coordinate, well, it's a little less than 1/3 of the way from here to here, but it's more than 1/6 of the way. So the nearest whole number would be about 2 units less than 11, which would be about 9, but that's a little low. Okay? Should probably be about 9.5 and maybe 1.7. Okay? So actually, I would say 1.7, 9.5. Let's test that.
I hate decimals on graphs.
It's okay. You don't have to deal with them right now. Okay. I've got this and I've got this, right? At the point where these intersect, well, this describes points on this line, this describes points on this line. If both lines intersect, that means this has to be satisfied and this has to be satisfied. So that gives us the simultaneous equations, y equals negative 4/3 x plus 37/3, and y equals x plus 8. Okay? Well, that's 2 simultaneous equations and 2 unknowns. I can solve it in any number of ways, right?
So we're basically doing how we did with the depth and time to find another equation that's opposite. All right.
Yeah. Well, yeah, we've got these 2 equations. If I solve these equations simultaneously, that'll give me the coordinates of the x and y coordinates of this point. So let me do that. But we've also estimated those. So what we get here had better be pretty close to our estimate, right? Or our estimate ought to be pretty close to the real solution. Okay? Well, there are a couple of ways I can solve this. I'm just going to do this. Y equals negative 4/3 x plus 37/3, and negative y equals negative x minus 8. In other words, I multiply this equation through by negative 1, and then I add them, just like we've done in the past. Okay? In other words, here's my first equation. Here's negative 1 times my second equation. So this is totally equivalent. These 2 equations are totally equivalent to this. Any solution to these equations will be a solution to these equations, and vice versa. Now, I add these, and I get 0 equals negative 7/3 x. And let's see, negative 8 is going to be negative 24/3 added to 37/3. I get 13/3. If I multiply through by 3, then my denominators go away. I get this. Now here's 3 dots that I know you love.
etc., etc.
But x is going to be 13/7. Okay?
13/7.
Well, that's a little less than 2. That's about 1.86.
You said that you was
Just to compare with my decimal here.
Oh, okay, I get it.
I estimated x equals 2 at this point. Really, x is 13/7, which is just a little less than 2. 14/7 would be 2, right? Okay? So there we have it. And now I can take this value of x, not this estimate here, and plug it in to one of the equations. This would be really easy, wouldn't it? So I plug into this equation, and it tells me that y equals 13/7 plus 8. Okay? 8 is 56/7, so that's going to be 69/7, which is 9 6/7. Now I estimated 9. I said it'd probably be about 9.5 because I knew that was low. But 6/7 would be like 9.86. Okay? So the actual coordinates of the intersection of the lines, using my estimates, because this is all based on estimates, there's bound to be some error in these estimates, right? I'm eyeballing these. I'm not measuring it with a micrometer. Okay? So actual would be 1.86, 9.86. So this wasn't bad, this is a little better. Okay? And if you do this correctly, you'll get immediate feedback. If you solve these equations and don't get something kind of close to what you estimated, either your estimate was off or one or both of your equations was off or you messed up your solution. Okay? So I'm going to assign you some problems of that nature.